Hello, let's talk about mean and data variability. Okay, first let's talk about a population versus a sample. Should be review, but maybe you haven't thought about it in a while. Let's say this is our population. Maybe it's like the whole world, I don't know. And there's a bunch of pieces or observations or people, however you want to look at it. Maybe this is our sample. And so maybe we move a bunch of these over here into our sample. So essentially our sample is just a subset of the population. Usually we will be dealing with samples and calculating with samples. X bar, or X with the line above it, is our sample mean, which is the sum of all your data divided by n, where n is the number of observations, or the number of people, the number of numbers, the number of pieces of information you're dealing with. So for example, let's say we're talking about number of siblings. So let's say our data is 1, 3, 7, 2, and 1, and I'll put it in these little brackets just for fun. So in this case, we have 5 pieces of data, so n equals 5. So our mean, our sample mean, or x bar, will be 1 plus 3 plus 7 plus 2 plus 1 all over 5, which is 14 divided by 5, which is 2.8. And this is really our balance point of our data. Sometimes it's called our center of mass. So if we look at it's kind of like a bar graph. I don't know, we're just gonna look at the data. So let's say this is 1, 2, 3, 4, 5, 6, 7. Oh, just barely fit. So if we kind of plot our data with x's, we had a couple of 1s. Let's make that 2 x's. We had a 2, we had a 3, and we had a 7. Now, if we look at where our mean would go, it would go just right under 3 right here. So this is our balance point. And really, if you think about a teeter-totter, I feel like there's still teeter-totters in some of the playgrounds. Maybe you guys played on teeter-totters at some point. But basically, the further away you are from, I think it's called a fulcrum, or the center of that, in our case, the balance point, the more impact you can have. Like you can, the 7 out here would really pull down on the teeter-totter, okay? So if you kind of look at the balance, kind of the weight, that's about the middle, because here's a 1, 2, 3, 4, almost 7, and there's a 7 over there, okay? Hopefully that made some degree of sense. But basically you can think of this like a teeter-totter, and the mean would be that center point. And basically the purpose here is to keep in mind that extreme values, like that 7, sometimes they're called outliers, greatly affect the mean or balance point of the data. Back to the teeter-totter for a second. Let's say over on the left over here, you have a few people sitting. Without anybody on the right, you'd be sitting on the ground, right? And the 7 comes, it kind of balances you out. So again, if the teeter-totter analogy works for you, great. If it doesn't, that's okay. Now let's talk about data variability. This is just how much the data is spread out. Okay? One way to measure data variability or data spread is range. This is one option. So let's say we have some data, 2, 6, 14, and 21. Well, our range is the max minus the min, right? So it would be 21 minus 2, which is 19. Now let's say we take that data, 2, 6, 14, and 21, and add 87 to it. Now our range is 87 minus 2, which is 85. So our range just changed a ton, and all we did was add one value. So basically, range is not helpful, or not very helpful, when you have outliers, because it only looks at highest and lowest values. Let's talk about another way to measure. It's called standard deviation. I know you talked about this in FST because I teach FST. So let's talk about it again. Standard deviation. This is just the average distance away from the mean for a set of data. So let's use the same data set we had before, the one without the 87. Let's use 2, 6, 14, 21. Our sample mean, or our x bar, will be 2 plus 6 plus 14 plus 21 over 4, which is 43 divided by 4, which is 10.75. Now let's make a table. So we have our x's, 2, 6, 14, and 21. We're going to put our x bar here, and so it's 10.75 in every case. It's the same data set. Next, we will do x minus x bar in this column. Again, x bar is just the sample mean, or the x with the line above it. So 2 minus 10.75 is negative 8.75. 6 minus 10.75, negative 4.75. 14 minus 10.75, 3.25. And this last one will be I'm sorry, 21 minus 10.75, 10.25, so we're good. Okay, our next column, x minus x bar squared. The purpose of this is really just because we have some negative values in the prior column in the x minus x bar, and we don't want anything to be negative. So if we square negative 8.75, we get 76.5625. Square negative 4.75, 22.5625, 10.5625, and 105.063. Okay, so from this data, we can find the sample, because we're dealing with samples, variance, And this is S squared. And this is basically the average squared distance away from the mean, which indicates kind of nothing, but we'll use it to get to standard deviation. And this is the sum of x minus x bar squared. Remember, the sigma just means add them all up, so add up all those squared terms over n minus 1. And so the sum, if you add all those values up, you get 214.751. So then the numerator of this fraction here is 214.751. We have 4 values in our data set, so down here is 4 minus 1, and you get 71.583. So that's our variance, which in itself is, fine. But our goal was to find the sample standard deviation. Or rather, that's what I'm, showing you how to find. Whether or not that's your goal is another issue, right? So this equals S, which is really just the square root of our S squared that we just found. Formula-wise, it's the square root of this kind of ugly thing, the sum of the x minus x bar squareds over n minus 1. But we already found that. So all you need to do to find the sample standard deviation is take the square root of our sample variance. The square root of 71.583 is about 8.46. So what that means is that on average, the data points we have, 2, 6, 14, and 21, on average they're 8.46 units away from our mean of 10.75. Keep in mind, we will use a spreadsheet for this, but I wanted you to be shown either for the first time or as a review how this works and where this comes from. But we will use a spreadsheet. Okay, so let's look at the spreadsheet we used on Tuesday, where we calculated all this stuff, and I have my, small amount of made-up data. But now, if we want to find standard deviation, or our average distance away from the mean, we can do equals standard deviation. Let's see if we can find it here. There we go, STDEV, standard deviation, left parenthesis, going from top to the bottom of my data, close parentheses, enter. And just like the other ones, you can copy it all the way across.